Now, for the problem 7 of 4.2, this is the last problem in this lesson. So let's get out. We will look at the problem. And it talks about a woman suing a computer keyboard manufacturer, charging that her repetitive stress injuries were caused by the keyboard. That's really interesting, isn't it? The jury ordered her $3.5 million for pain and suffering, but the court then set aside that award as being unreasonable compensation. I would say so. In making this determination, the court identified a normative group of 27 similar cases and specified a reasonable award as one within 2 standard deviations of the means of rewards in the 27 cases. The 27 award amounts in dollars of thousands of dollars are in the table below. Now, let me say this. When you see things like 2 standard deviations, 3 standard deviations, that becomes a very important thing in statistics. And I believe, if I'm looked ahead, I believe that in either 4.3 and the lessons in 4.3, 4.4, 4.5 talk about what is called an empirical formula. And in that empirical formula, they specify in a theorem, it always holds true, that if you want to know what the percentage of the original data items, these items like this, fall within 2 standard deviations of the mean, it gives a percentage for that. And so we'll get to that empirical formula soon, but this is kind of a whet your appetite, get ready for it. So in 2 standard deviations, what we need to do is to find the mean of this, find the standard deviation of it, multiply 2 times the standard deviation and add to the mean, and that should give us the maximum possible amount of dollars that could be awarded, okay, under the way the court gave her an award, a reasonable award. Okay, so we'll hit this solve. Loads it. Very good. We will stop and share. Now we need the mean and we need the standard deviation before we can work the problem, right? Here's the mean is $747, and we're going to round it off 44 cents, right? But we're supposed to round the maximum, I think, to 3 decimal places. So why don't we hold this and round at the end, okay? So the mean, and I'll write it down, and then we'll go to the document camera and work it out, was equal to 747, 4, 4, 4, 4. And the standard deviation is equal to 606.9738. Okay. Now, let's close this. And we will go to the document camera where I put the information down. Maximum is mean. Remember, the mean is X bar. Standard deviation symbol in math is little s. So I'm going to take X bar plus 2S. And so here's what X bar is. What is what S is. So I'll have 147.4444, and we'll leave it that way, okay, until the end, and then we'll round to 3 decimal places. Okay, and so we'll take 2 down times S, which is 606.9738. Okay, if you have your trusty little calculator handy, you can put these out. First we'll multiply here, then we'll last add, okay? So we'll take 606.9738. Multiply that times 2, and we get 147.4444 plus, and this should be 1213.956. So we'll add these two together, plus 147.4444, and this gives us 1361.4004. Okay. That's 2 standard deviations above the mean. So fishy. This should be more than this. 1 and 1 is 2. Let's see. That's right, because this is hundreds and this is thousands. 6. That doesn't seem right, but let's go back to the screen and see what we have here. See, I didn't get it. What's wrong here? Let me check my figures, because I got 1361 and they got 1961. Where did I goof? Let me go back. Salts. Okay. Oh, I put the mean as, let me see, it's 747 instead of 147. I couldn't even read my own writing, I guess. So let's go back now and rework the problem, okay? We'll go stop the share, and we will go to the document camera. I took this as 147 instead of 747. That's my mistake. I apologize. So now, let's do it again. And that's better. Now we'll take 1213.956 plus 747.4444, and I get 1961.4004. Okay, and I think I'm going to round that to 3 decimal places, which is 400, I think. Let's go ahead and go back to our problem and check it again. Well, I got 1961.400. And guess what? It would count it wrong because the answer is this. So apparently, what they did is they rounded everything to the nearest cent rather than carrying it all the way out to the end like I did and round at the end. Well, anyway, I believe if you round it to the nearest cent up here and here, then go, you'll get 0.392 instead of 0.4. Well, anyway, I'm going to let you try that out. And I'll have to watch because when you do the 7 in your homework, if you get it wrong, I want to give you credit for it because they didn't tell you how to round. They just told you to round at the end, 3 decimal places, which is usually the way I work, is the way they usually work it in engineering type problems. You don't round until the end. So, but anyway, that's how to work the problem.